This is practice 1, and in here we are going to create a 4 by 3 array in the beginning, and then we take a subset from this original array. So in this example, we just take the first 3 and first 2 column and make a new subarray. After that, we try to replace one single element variable with another one with the 0. So in here, we replace 5 with the 0 and create a new subarray as an output. Okay, so in the LabVIEW program, I already made starting the array here. So I already made a program, but in order to show you how to do that, let me just redo everything. So first you have to make an array. So if you go to the data container and then there's array, so click this one, and then you have to create the numeric control and fill in this container. Right now this is a one-dimensional array, so right now this index indicator has only one number, but if you want to make a 2D, you can just expand this index number indicators, and then you can expand your array size to show the array. So the first one indicates the index number for row, and second one shows the index number for column. So this is a 1, 2, 3. I just manually type the array elements 6, 7, and 8, 9, 10, 11, and 12. Okay, now we just create this array. So we want to take some subset. So go to the block diagram and click on the right button, and there's array folder. There's the many different array functions here. I want to take the array subset here. This is array subset. So this is array subset. I want to show the label of this function so that I know that what this is for. And if you connect this one to this array subset, you see the 4 input connectors appear. In order to take a subset, we have to specify from where to where on the row size, from where to where for the column side. So I want to take from the first 3 row. So my first row has an index number of 0. So I just go to the index and then create constant. So this is a 0. And I want to take first 3, so length is 3 row. So this is length is 3. And then for the column, I want to start a 0, the first column, which is a 0 index number for column. So this is 0. The length is 2, because I want to take only first 2 column. Okay. And after that, we can create the array indicator here, but a simpler way to create indicator is just go to the output of this function, click right button, and create indicator. So this is a subset. So let me just expand my array to show whether the output is correct or not. So when I run, now we successfully take the first 2 column from my original array. Okay. After that, we want to replace 5 with the 0. So we just go to another array function. At this time, replace subset. I want to replace elements. So just click this one. And then I want to start from this created subset. So your input should be from this one. Then after that, which one do you want to replace? I want to replace 5. So what's the index number for the 5? This is located at the second row and second column. So by index number, this one should be 1 by 1. Okay. So that's why I have to create constant value. This is 1. This is locations of the row. and the second one is 1 of column, so I just connect the 1 to both of this one. And then new elements is I want to replace 5 with a 0, so my new element is 0. And after that you create indicator, so let me just move this one to the bottom, and if I run one more time, now you see that your 5 was replaced with a 0. This is practice 2. Using a for loop or while loop, let's create an array with 10 elements. So in 10 elements, it starts from 2 and with an increment of 2 up to 20. You can just quickly make an array and then you can manually type it in, but in here let's use a for loop or while loop, so automatically fill in all the array with these increments. In order to do that, let's use the for loop first, and go to the structure, and then there's the for loop here. So let's just make a proper size of for loop, and then we are going to create an array with the 10 elements. So we know that the for loop should iterate the 10 times, so I want to connect this one to 10. After that, in order to generate the number starting from 2 and 4 and 6 and so on, I want to use this loop iteration. So I know that the loop iteration starts at 0. Okay. So what I want to do is that we want to just multiply 2 and start from this kind of looping window. So because this one starts from 0, that's why I want to increase 1. So I go to the numeric, and then this is increment 1. So first let's try to increase 1. So which means in the beginning this output should be 1. But in order to make this one is 2, I want to multiply by 2, right? So this is multiply like that, and then this create instant 2. So which means this output, okay, at the beginning is 2, and then when I is 1 and this I1 is added, there's a 2 times 4. So when I is a 2, 1 is added, 3 times 2 is 6. That's why we can just generate the even number of the 20. Okay, and after that you can just connect this one to the exiting edge on here. Okay, then if you click this one, you see that this turner looks like hollow, it's not solid. Okay, so if you on the right click here, you can see the turner mode. In the turner mode, this is indexing, last value, or concatenating. So indexing value means whenever this one is iterates, the new value will be stored into the memory. After that, once the for loop is end, then all the 10 value will all once dumped into the array. So I want to create here the indicator. So this one becomes our array, because whenever this one 10 times repeats, that 10 each different numbers are stored into memory until the for loop kind of finished. Okay, so I think that's it. So this is all we have to do. So if I just show you the results, if you run it, then this one automatically fill or the array from 2 to 20. In the slide, there's alternative way to make this program. So please just look at those alternative way to understand there are other ways to implement this program. This is practice 3. I think this is pretty similar to practice 2. We create an array or vector with 10 elements, but the elements has a different pattern. So 1 over 2 and 2 over 3 and 3 over 4 and then by n plus 1. So the last element should be 10 over 11, right? So you can just simply modify your previous VI, but at this time let me just show you alternative way to create this array filled with the 10 elements using for loop. Again, so let's go to structure and the for loop, and then we know that this one should be repeat 10 times, so I just create a constant for 10 repeating time, and after that this I is keep increasing from 0 to 1, 2, 3 and 4, something like that. So however in here we want to start 1 over 2, so as we did last time, we just increase this looping iteration number, so which means this one starts from 1. Okay, and then denominator is always one further added 1. So our denominator is this is 1, so with denominator is 2. So simply you can just copy and paste this one here. So this output should be added to, that's why this should be denominator, this is a numerator. So after that we want to divide the number like that. So our numerator comes from just 1 added, and denominator comes from the 2 added. So when I is 0, this is 1, so 1 is numerator, and then 1 more added, so denominator becomes 2, so 1 over 2. This is elements. So you can just connect this one to the X on the right edge and create an array. But at this time, let me show you a different way to build an array. And in here we can add a shift register. So on the left edge side, on the right click and add a shift register here. Okay, and then on the right click, if you go to the array, there's a build array in here. This is a build array. So inside here I want to build an array. So this concept is this is a new element. New element goes to the elements, and then I want to stack new elements to my previous existing array. That's the concept of build array. So I already when you begin this for loop, you have to create existing array first. So and then whenever the new element is generated inside the for loop, then new element will be stacked onto the new array, that existing array I mean. So right now if you look at this, the line, thickness of the line, this line is thicker than this one, but this means this line has array size, and this single thin line represents a single scalar value. So in the beginning I want to start with the empty array, so go to the move your mouse cursor, click on the right, and let's create constant. Okay, so automatically this one create the empty constant array, and then after that you just repeat 10 times, and then all the new elements stack onto this existing array, and then later after the for loop ends, then it will exit our desired array. So now I just create indicator here. So this is array. Then let's run. So this is 1 over 2, 2 over 3, 3 over 4. This is 10 over 11. So now we can create the 10 elements as we repeat the for loop. And then however this is a little bit different from the previous one. In here we just create a single array and store into the memory, and then dumping everything into the one array out. But in here when we start, we create empty existing array, and those array, the new element is added to the array elements and keep running it, and after that we dump everything into the array. This is practice 4, and here using a build array, create 10 element array of random number, and after that we move through the array elements and set any value that is less than 0.5 to 0 and any value greater than 0.1 to 1. So after we create the 10 random number array, we actually convert that into either 0 or 1 depending on whether the element is lower and greater than 0.5. So, okay, so let's just use our LabVIEW here. We want to create array, 10 random number array. So we want to use the for loop here. So at this time we want to create the 10 elements, and then this one specifically asks us to use a build array. So I want to add shift to register. So click on the right and left button. This is shift to register, and then I want to add the build array. This is build array, and I just expand this one. So my previous one from the existing one, and your appended array should go to the next iterations, and then I need to create a random number. So where I can find the random generator. So in the function here, there's a search. So search and random. So random number generator is here. So I just double click. So this is a random number generator. I just bring this one to there, and then I just connect this one to this element. So whenever the random generator generate elements, it was added to the pre-existing array, and just keep repeating it. And on the left side here, I want to start with the empty array, so constant one. So in here, so this output should be any 10 random elements. Okay, let me show you. If you run, these are all the 10 elements with a random number. Then our next task is that we have to move through each elements so that we just convert it to either 0 or 1. Okay. So in this one, I want to just make another for loop. Okay, I want to make another for loop. So structure and the for loop here, and I just make the for loop here, and I want to take this array inside the for loop. Okay, so I just tap the wire and then click on the left edge here. So by here, this is a turner. This is actually, I just create a turner. So if you click on the left button, you see that this is the indexing, disable indexing. So if you disable index becomes solid, which means when this data passing through the for loop, the 10 elements all ones kind of passing through it. But if you make this is enabled indexing, any data from here is just single elements. So automatically this is a for loop. So whenever this one iterate one time, each different elements will be passing into the for loop. Right now this array has only 10 elements, so automatically this one will repeat 10 times. So I don't need to connect this number of for loop because I enable the index. That's why this for loop will be executed as many number of the with the same number of these elements. So from here I want to check whether this one is a 0 or 1. So I have to make the comparison and then case structure. So in the comparison, I want to say this is greater than equal to. So if this is greater than uh, 0.5, this is 0.5. If this is greater than 0.5, I want to just assign the 1, otherwise it's 0. So in here I need to make another case structure which is true and false. So if this is true, I want to assign 1, otherwise it's 0. Okay. So where I have to assign the either 0 or 1, you can just create another array. So in this for loop, I just make another shifter register, and then I just make another the build array. Okay. So this is a build array. And then I want to put constants. So these constants, the number constants from here. So this is 1. So this 1 goes to my new elements. And if this is false, I want to connect this one as a 0. Okay, this is 0. And this new element should be added to the pre-existing array, so I just connect this one to both shifter register, and then this one should be start with the empty array, like that. And then I think that's it. So I want to look at our final array output here. So this is array 6. So let's run. Now my first one is greater than 0.5. That's why this one is changed to 1. And second element is 0.5. So that's why it just changed to 0. So everything is kind of digitalized, either 1 or 0, by checking each element. In practice 5, still we are using a for loop and create an array that has 100 elements ranging linearly in the value from 0 to 10 pi. So we have to make an array with the 100 elements, but 100 elements start from 0 and ends 10 pi exactly. So actually we have to break down from 0, 1, 10 pi, 100 elements. So our logic is something like this one. So just imagine that you divide 10 pi by 99. So let's say this is your 1 divisions. Then everything else is the same, but if you just multiply 0 at the very beginning, and 1 and 2 and 3 and etc. and up to 99, then 99 is cancel each other, so it becomes 10 pi at the very last element, but first element becomes a 0. So we are going to divide 10 pi by 99 elements. Then we just multiply each iteration number from 0 to 99, so that we can create 100 elements. Okay, so in the LabVIEW, we use the for loop, and now we know that we have to repeat 100 times. And then after that, as I said, we have to compute 10 pi over 99 first. So where can you find the pi? In the pi, you try to search and pi. Then I can see the pi from math, science, scientific constants. So this is pi. And so we do some arithmetic operations here. So this is multiplications. I want to multiply pi and 10 and divide by 99, and this constant is 99. Okay, after that we have to multiply these whole things from 0 to 99. So let's bring the multiplication node one more time, and this number we just keep changing from 0 to 99 as the for loop iterates. So you can just connect this one to loop iteration number. So I start from 0 up to 99 because this is 100 times repetitions. So this is exactly each different element, right? And then you can just connect this one to the right edge. So this is enabled index number, and if you just connect to this one indicator, then you can run, and these are all those kind of evenly distributed elements from 0 to 100 pi, 10 pi. So now we have 100 elements, so it's not easy to just show all these elements, so that's why you have to change the index number. So if you want to check the very last one, 99, so as you see that this is a 10 pi value, right? And the 98, 97. So you can check each index number variable by changing this indexing number. In practice 6, we create a VI that requires an input array with either 1 or 0, and create LED array in which LED is on and off depending on the value in the input array. So in this example, we create 5 array, 1 0 1 1 0. Then correspondingly, this one creates the array that contain the LED light and turn it off depending on this input value. So in this one, I just explained how you create this one using this slide. So just imagine that you create this input array manually. Okay, so that's this one. Your manually created array will appear on block diagram, and then you can just create one for loop here, and then you can just connect the line into the for loop. So this is auto-indexing input. So by default, if you just transfer any data type through the for loop, this tuner will be auto-enabled. So which means whenever this for loop iterates, the value from this tuner is each element from the array. So now inside your each element is compared with the 1. If this is 1, that's a true, otherwise false. So true is on and false is off. So you just connect this one to the auto-indexing output as well. So all the true and false value will be stored on the memory until the for loop is finished. So after the for loop ends, then all the true and false data just goes to the Boolean type array. So you can create this Boolean type array manually, or maybe you can just try to click on the right button and create indicator, or maybe in this kind of case, in this one, for example, you can just create array in the beginning. So for example, you just make array container and then try to insert kind of like LED light. So you can just create this kind of array first, and then just connect the output from this right auto-indexing output to that array to display your outputs. And this is practice 6, and let me move on practice 7. In practice 7, we use a for loop and shift register to average data from your array. So these are kind of random number, so we want to get the average out of these array values. Okay, so in here, let's create any kind of random array. So this is array, and then click numeric control, and then I just placed inside the array container. Then let me just make all the number. So in our text we have 5 and 22 and 67 and 34 and 22 and 11. Okay. So let's say I want to get the average. In the LabVIEW there's one function that compute the average, but for the purpose of learning how to use function, for loop, and shift register, then let's build it. And go to structure and the for loop, and then you can just make a for loop here, and then you can connect this one to the left edge. So this is by default auto indexing input, so you can access each element. And in order to get the average, we have to add everything, right? So whenever this for loop iterate, we just keep adding using the previous data points. So in that case, we have to add shift register. So move your mouse cursor to the left edge, click on the right button and shift register, and then let's bring the add node. So I want to add the current elements to the previous elements. Okay, then that previous elements came from whatever the output from previous iteration. And then when I begin this for loop, I want to add the 0 value so that it doesn't have any bias. So this is just added everything. And then this output is the total sum of these whole elements in the array. Okay. After do that, in order to get the average, we have to divide by the number of elements, right? So go to numeric and divide, and I want to divide the total sum. And how many elements? Right now in this example we have 6 elements, so you can just connect the constant value 6. But what if somebody changed the elements? If I add one more, for example, let's say I want to add another one, then it becomes 7. So depending on how many elements user input into the array, you have to automatically change the number of things that number of divisions to get the correct value for the mean. So basically that number came from this loop iteration, because whenever this one is iterate, this one is kind of keep increasing. So I want to just connect this one to here, but this time I don't need to make this as auto indexing, so I just need whatever the max value from this loop iteration. So click on the right button, and tunnel mode is last value. However, this I starts from 0, so I have to add 1. So numeric and go to the 1 increments. So this is 1 increments, and this one should be number that with that you divide your total sum, and this is your output. So this is constant indicator, so this is mean. So let's run. So this is a mean of this 7 variable. So for example, if you just add one more thing, so let's say I want to add 100, and if you run, you can accurately compute the mean value automatically. This is practice 8. In practice 8, two arrays are given, X array and Y array. And using this two array, let's create two-dimensional array as an output. So this is our desired output. So as you see that 4, 1, 6, 6 to 7. So X, the first element of X is multiplied with 6 to 7 to make element for the first row, and then the second element of X is multiplied to 6 to 7 to become the second row of your two-dimensional array, and so on. So you see the pattern. So 4 should be multiplied to 6 to 7, 1 should be multiplied 6 to 7, 6 should be multiplied to 6 to 7, and so on. So that's why if you look at this kind of templates of programming, X, Y has each 3 elements. Okay, so we are going to use the 2 for loop here, and this outer for loop here, this is auto indexing. So which means X has a 4, 1, 6. So when this data transferred the outer for loop, this one is automatically changing 4, 1, 6. So let's say at the beginning of the for loop, the 4 kind of passing through it. Then inside the for loop, the 4 just passed through it. This one doesn't have any indexing. So this is 4. But inside the for loop, it's kind of iterate 3 times because the Y has 3 elements. So in the Y elements data pass through the outer for loop without indexing, which means 6 to 7 is kind of passing through it, and only inside the for loop the 6 to 7 is kind of transfer element by element. So this is 4 and this is 6 to 7 depending on these iterations. That's why this the first row actually the first row 3 elements will be created, and next one is 1 goes through the 1, the second element of X pass through here, and then 6 to 7 is kind of iterated, so multiply them and so on. So let me just show you how to create this VI. So we have to create X and Y, and let's say this is X, and we have 4, 1, 7, 4, 1, 6. Okay? And then let's create the Y as well. I just copy and paste, and this is Y, and this is a 6, 2, 7. Okay? So we create the 2 array, and then let's make a for loop. Okay, so this is case structure and for loop. So we have to make one outside and one inside. This is inside for loop, sometimes called nest for loop. And now let's pass through this one. So now I want to make this is enable, auto indexing enable, and then pass through this one here. But at this time automatically this is just the elements, right? So I can access 4 and 1, 6 inside of this nested for loop, and this one goes to passing through it, but I want to pass all 3 elements at once. So I want to go to the click on the right click and disable index, and then I just connect this one to make this is index. So now inside the for loop 6 to 7 will be accessed. Okay, then we have to multiply them, so we just multiply these 2 value, and then goes to exceeding 1, this is enabled. So whatever the number of multiplications is stored onto this memory, so basically after this nested for loop end, the 3 elements will be created. So that becomes the new row. And then after that, this value goes through the outer for loop. So now if you look at the thickness of the line, this is single elements. It becomes the 2D elements. And then this is actually array. So array is kind of stored onto the memory. So array itself, the 3 elements itself kind of stack together to become 2-dimensional array at the end. So if you just create indicator, now you see the 2 line because this becomes a 2-dimensional format. So let's run. Now we have this array as an output. We don't need to connect the number of repetitions of the for loop because this auto-indexing and this is auto-indexing. So whenever it just accesses each element, it just automatically know how many times this one should be repeated or iterated. Okay, so this is number practice 8 and practice 9. The first part of practice 9 we already done in the previous practice. So we set up an array that has 100 elements ranging linearly in the value from 0 to 10 pi. And then, but we have to add another feature using a case structure. Count how many of entries are positive among this number. Okay. So let's go back to what we did previously. So I didn't delete what I did before. So this is what I did before. So I just created this for loop. So this one create 100 elements, and each element is evenly distributed from 0 to 10 pi. Okay. Then I just want to count each element so that how many elements are greater than 0. Okay. So this one should be pretty easy. In here, I just want to compare and these elements. If this is greater than 0, I just add one count number. Otherwise, I didn't count. So in here, I want to add structure and then case structure here. And then if this value is greater than 0, so I need a comparison. So comparisons over there. So if this value is greater than 0, let's say 0, then I want to add my count number. Okay, so my count number actually should be referenced from my previous iteration as well. So in this one, I want to add shift to register. I want to shift to register, and my shift to register, and then I have to add one increments here. So right now I just connect this one through this true statements and then just connect to there. So if this is true, I just want to add 1. Otherwise, this is false. I just connect the previous value to the next to the exceeding the shift to register, so that the previous value won't change for the following iteration. And then this iteration starts from 0. Okay? And then if you just create one indicator, then this is an indicator, number of positive numbers. So if you run, then everything is 100. So let me read this one. Oh, okay. So set up an array. So I actually forgot add one more sentence here. So after you create 100 elements, you have to compute the y value. So y, let's say the y is a sign x. Okay. So let's say this array is a x. Then you can get the result from the sign x. Then using a case structure, count how many entries the entry y are positive. Okay. Then so rather than we just compare this x entry x value, we just insert the sign function. Okay. So where can we find the sign function? So let me just try to find the sign function. It's under trigonometric function. This is sign. Sign function is here. So this is my sign function. So you can connect this one to the sign functions, and this output of your sign function should be compared. And then I want to see how many sign function output is positive. Then if you run it, then because the x start from 0 to 10 pi, so sign is going to fluctuating around the 0. So exactly half of it, the half of the entries are greater than 0. So this logic is pretty simple. You can just compare whatever the elements, and if that's the true, then you just add 1. Otherwise, you just pass it through. And practice 10, we create 4x7 array of random number, and then move through the array element by elements and set any number that is less than 0.20, any value that is greater than 0.4 to 1. I think we already did a pretty similar practice before, but let's try to implement this logic or write up LabVIEW. So 4x7 array. So we want to make a 4x7 array using the for loop, using the random array. So in here we can use the for loop. This is for loop. So first time this is 4x7. So 4 in the row, I want to repeat the 4 times for making each row. And then inside the for loop, I just create another for loop. And in this one, I want to repeat 6 times, 4x6. 7 times, right? Because I have to repeat the 7 elements for the 7th column. And in here, inside, I want to create the random generator. So let's try to find the search random number generator. So this is a random number generator here. And then you can just connect to here. So this is auto indexing. So whenever inside a for loop is iterating, this one actually stops. All the elements will be stored into the memory, and the outer should be 1D array, and the 1D array goes through the outer for loop. It becomes the 2D array. So this indicator. So now this becomes 4x7. Let me move this one. So if you run, now you just create 4x7 array with random or random values. So this one, this is pretty unique and simple way to create a 2D array with a random number. And our second task is that we have to check each element so that if element is lower than 0.2, we convert that to 0. If greater than 0.4, we convert to 1. Okay, so now we try to make another kind of array. Okay, so we have to check each one of them and just try to do that, convert all the array. So what we want to do is that we just try to make another for loop array. Okay, so in here I want to make a for loop, and then if I just connect this one to my for loop here, so this is auto-indexing. So that means if this 4x7 array kind of path through it, you can access inside the for loop only the first row. Okay, so this is 1D array. So inside of for loop, you can just make another for loop. Now this one is connected to inside here. Now this is one-dimensional array, and this is a single element. So inside this for loop, you can access each element. Okay. So now if each element is lower than 0.2, and we change to 0, greater than 0.4, we change it to 1. Okay. So we need a comparisons. This is comparisons. If this is greater than, lower than, if this is lower than 0.2, this is true. So we need a case structure, true and false case structure. Then I want to put the 0. So let me go to the constant value, and this is 0. Oh, constant value, this is 0. Okay, so if this is lower than 0.2, definitely this should be 0, should become out. But otherwise, we have to think about another case. Otherwise, if this element is greater than 0.4, it could be 0.3, but only when this element is greater than 0.4, I want to change it to 1. So I have to compare this one again. So using the comparisons, it's greater than 0.4. If this value, okay, is greater than 0.4, if this is true, so I have to make another case structure. Okay. If this is true, so I just connected it, okay, and then this inside constant should be 1. Okay. 1, and otherwise the previous existing value should go on. Okay. So let me make this one is a little bit bigger so that we can make our program looks a little bit more readable. And this one too. So I just made this one is a little bit wider so that we can add more programming into this space. So right now we want to convert any value lower than 0.2 with 0. So the logic is that we can use this array replace subset because we already created this array, so we just replace that array using this number, using this one. So right now I want to access my previous existing array. So this is array should be actually tapped from the outside to the inside. Okay. But in here, I need to make disable. I need to disable all the indexing array because when I reference the pre-existing array, I have to take all the array 4x7 format. So I have to disable this one. I have to disable this one. So in that case, I can replace whatever the index number using this 0, like that. And then when the elements, specific elements, the current element is lower than 0.2, the current element indexing number is exactly the same as this looping iteration. So because outer for loop actually indexing is for the indexing for row, inside the for loop is indexing for the column. That's why this looping number is exactly the same as the indexing number for the row. And this looping number is the same index number for the column. So right now I can just replace the current elements with this 0. Okay. And then I have to dump into this one to the pre-existing array. So in this one, another things to reference the pre-existing array, you can just go to your array on the right click and then create a local variable. Okay, create a local variable and just place that into this one, and then I want to replace that and then dump everything into the same array. Okay. I only change the current elements with this indexing number, then just change this one. Okay. And likewise in that false, if the element is greater than 0.2 but it's greater than 0.4, okay, then I need to change into the 1. So I just do the same thing. So go to the array and then replace sub-indexing number here, and then I just get my pre-existing array from this one here, and then the row index number is the same as this one, and the column is the same as this inside of looping window, looping iteration number, and 1 is replace the new elements, and again this is creates. Go move your mouse cursor to array 11 and then creates a local variable, and then I just dump everything into the same array. Okay. And how about this false? We don't need to do anything because if the elements is between 0.2 and 0.4, we just take whatever the original value, so we don't need to do anything. So this is originally created array 11, but when I run this one after I add the second part of the VI, then some of value will be changed. So for example, but I see some typo here because this one is lower than 0.2 but it doesn't change to 0. So let me try to see. I don't need this one here. I try to make another array to compare the randomized array and then modify the array. Okay, then I have some error right now. Let's see. Okay. So when something is greater than 0.4, in here I realized that I made a mistake here. So right now using this 2 for loop, we created 4x7 randomized array, and this one is connected through the second part of the for loop, so that we can change any elements either to 1 or 0 depending on the conditions. But when I run this one, I found that only the very last one is only changed. The reason is that when I run this program, this is creating the randomized array. This is directly connected to input of the second part. So even though I change some elements in the middle, it will be replaced by these randomized elements. So my mistake is that one. So I just disconnect this one. Instead of I directly connected from this one to the second part of it, I created here, I created a local variable. I create a local variable. And then this is kind of, if you look at this one, you can connect only from left to the right, but you have to get the data from this one. So you have to click the right button, and you have to change this one as a creates. You have to change the property, change to read. You have to read the data. So now you can just connect this one to there. So in any case, this one is kind of separated. So whenever I just run this one, our changed elements won't be replaced by the original randomized array again. So let me try to run. So I realized that my mistake is that how we reference our array to update it. So a while ago I just placed this one, I referenced your pre-existing one from the outside here, but this is kind of mistake. So when I just move this one inside here, so this is a local variable of array 11, okay? That whenever whenever the condition is met, I need to change it. So that's why when I reference the pre-existing one, this pre-existing array should be read inside of your nested for loop. Otherwise, your pre-existing array is kind of replaced by the original array. That's why you cannot get exact the answer. So for example here, if I run it, so in here, in order to show the difference between the changed one, unchanged one, I just create array 12 here. So array 12 has original randomized elements of an array, and then basically each element is read from this original one, and just see the comparison here. And then whenever if you want to update your array, you can actually reference your array 11 inside of nested for loop, and then this one is changed and update your array 11 here. So this one should be done inside of the current iteration. So this data should be read, your local variable, from inside a for loop. Otherwise, only the very last element will be updated. This is assignment 1. As we did from previous practices, we try to make a two-dimensional array using the for loop. But when you create elements, the elements should follow this kind of pattern. And aij xi divided by 2 plus xi plus yj. So in this one, each ij represents the position of row and column. So for example, if you try to make 3 by 3, so this is A11, A12, A13, A21, A22, A23, A31, A32, A33. So A11 is equal to x1 divided by 2 plus x1 plus y1, because in here I just follow this ij, right? So when I is 1, j is 1, I just replace ij with this number. How about A12? A12 is I is 1, j is 2, so this is x1 divided by 2 plus x1 plus y2. So each element should be computed by using this equation. So I is a row number, and then j is a column number. So with this one in your mind, let's try to make those kind of two-dimensional array. So we are going to use two for loop. This is outer for loop, and then create another for loop inside. Okay, and then let's create the array. So this is our x, and inside the array then we put the number, and this is 3 elements, and our x is 4, 1, 6. Four, 1, and 6. And let's create the y. Y is 6 to 7. 6 to 7. Okay, so now each element is x divided by 2 plus xi plus yj. So this x actually for the row, and these are all the column. So let me just connect this one here, and then connect this one here. So when I'm passing this 416 through this first for loop, and 416 kind of path through it, 4 kind of path through it, and then this one I want to disable index and enable inside here. So whenever this variable, this elements, actually when the inside for loop iterates, whenever it iterates, this 6 to 7 actually come out from this node, but this one is fixed by the outer for loop. Okay, So for example, this is 4 and this is 6 to 7. Then our elements in here, xi divided by 2 plus xi plus yi. So this should be our x. So let's go to the numeric and divide. So this x divided by and 2 plus xi plus yj. So let me just add everything. So I want to add 3 things all together. So the first value should be constant 2, and second one is x, and third one is this y, okay, yj. So you can consider this outside looping I is I, and inside looping iteration number is j. So you can think about I and j, and then this one should be this one goes to a denominator, and then this one pass through this one, and then you can just create indicator. So let's run. So these are expected outputs. So we just created each element following these equations. This is assignment 2. Using a for loop, write a VI that creates an array that ranges from 0 to the number you specify. So this VI actually creates the elements with increasing number from 0, but when you stopped the position that you stopped the array is depending on the user's input. So when someone just put 8, then this array 9 element array will be created, and then if somebody put a 10, the 11 element array will be created. Okay, so let me just create that VI at the bottom part. And first, let's try to get the user input. So this is number. So let's say I want to put the 8. Then using the for loop, so we go to the structure and for loop, okay. And at least I know that maybe we can implement this one using either for loop or while loop, but maybe let's try to use the while loop at this time. I think while loop should be more easier way to do it, the while loop. And then we are going to this looping window to fill in the elements, okay. And in the while loop, first let's add the shift register here, okay. Let's add the shift register. And then I want to use the build array. Okay, build array. Go to the array and then build the array. Then means this looping iteration starts from 0, so I want to add the new elements as this one kind of iterates. Then I want to add those new elements to the previous existing array. So I want to create the empty array right now, So whenever this one iterates 0, 1, 2, 3, 4, those kind of numbers keep adding to the new element, new array. Then when do you want to stop it? I want to stop this one when this number is equal to this numeric number, right? So you have to go to comparison. So if this looping window is equal to greater than if this is greater than equal to the user's number inputs, then you have to stop it. Okay, this is stop condition. After that, you just assign the output from the right shift register to indicator, which is the array. So let's try to run. Okay. Now it just fill all the elements of array from 0 to the 8, because this is a while loop and it's keep iterating, and then I is keep changing, and then this is just conditions. So you can create this number of elements. So let's say if I change to 10, then it will just fill up to the 10. This is assignment 3. In this one, you are required to write the VI by following this template here. So this is your input. This is your input element, okay, and this is input array. So create these two array before you begin. So when you create these two array on the front panel, you can see this icon on the block diagram. Okay. After that, you want to insert the very first row into here. So that's why you use the build array. Okay. It becomes this X array. And then you just create another array filled with 1.2. So in here has the same size with the X. So this is array size. So if you just connect this array size, this one just determine the size of the array. So right now the array size is 5, so this one should be 5. Then this is initialized array, so it can create the specified number of array depending on what number you connected to there. This is length of array and filled with 1.2. So that's why this Y is the same as this one. And after that, you subtract the two array. So you subtract X and Y, and it becomes X minus Y array. Okay? So if you understand this program, you must write a VI on the LabVIEW and see whether your VI works as you expect. This is assignment 4. In assignment 4, we provided 3 array. So this array represents a score value from different exams. Okay. And after that, we want to compute the final grade. But this final grade has some weight. So exam 1 weighted 30%, exam 2 weighted 30%, and the final exam is has a more weight than the previous 2 exams. So you can just when you compute the mean, you try to compute the mean through this kind of weighting system. So let me try to make this VI. So before we do that, in order to for my reference, let me just copy this one onto this side so that I can easily reference it, look at the number. Okay, so let's try to get the to create the array, and I want to put the numeric number. So first one is the 90, and then 80, 70, and 60, and 50. So this is exam 1. And then let's copy exam 2 and let's say exam 3. So this is final exam. And of course the exam score are not the same, so I have to update. 63 and 92. 70. Okay, now we have 3 array here. Okay? Then we want to, so the first exam 3 has a 30%, exam 2 has a 30% weight, final exam at 40% weight. So when you try to get the mean, you have to just multiply 0.3 to each, 0.3 to exam 1, 0.3 to exam 2, and 0.4 and exam 4, and just add them up. So I think that should be pretty easy. So in here you go to numeric and multiply. So you can go to before I do that, let me just let's try to use the for loop. Okay, choose the for loop and go to structure and the for loop. So I want to access each element when for loop iterate each time, and what I want to do is that I want to multiply each element depending on the weight. So this should be 0.3, and this is 0.3, and the next one is 0.4. Okay. After that, I want to, we have to add everything. So this is multiple addition, so I just use this one. And this one go through the indexing, auto indexing, and then this is indicator. So this is the mean value. So if you run it, so we have this kind of mean value already. So this is it. But in this kind of problem, we can, it's not necessarily to use the for loop. What I mean is that if you want to just multiply each weight and add, you can simply multiply the array with the scalar. Okay? You can simply multiply with vector with a scalar, and then you just add all the vector together, and this is indicator, this is results. So this is our results. So if you run it, you know that this array 3 and the results are all the same. So in this for loop, we just access each elements and then compute all the weights and add them up to give each element to the array. But in the bottom one, we just compute all those weight. We just multiply the weight value to the array at once. and then later we just add them up. So this is more pretty easier way than use the for loop.